Hi, good morning to all. Today we are going to see about the analysis of singly reinforced beam by a limit state method, and here I'm going to deal with the uh, study about singly reinforced and doubly reinforced, singly reinforced and the doubly reinforced beam, and the design and the nature of the beam, and we are going to see about the method of limit state method, how we are going to design a singly reinforced and a doubly reinforced beam. So before going to the topic beam, the singly reinforced beam, let me have some share some um thing normal things, I mean, basic things about a beam. So you all know this is a lateral member, and which has a concept of a lateral load, and which is an horizontal member too. Okay, and in which the horizontal members undergoes the lateral load. A couple of tends to bend in horizontal bar, undergoes the bending stress is known as an a beam. This we know, and this is the type of an a beam which is an cantilever, simply supported and overhanging, continuous and fixed, and continuous and simply supported. So this we have seen in strength of material and mechanics of solids before in the structure, and this is an just an overview on beam that as with reinforcement in field. And here we are about to see about what is the type of beam we are going to design here, first of all. So already we know what is a type of a beam that has been seen in the practically we use as a continuous or a simply supported. Now we are going to see the types of beam, that is singly reinforced beam and a doubly reinforcement beam. So here we may see this two structure of reinforcement, the cross section of the reinforcement of a beam, which is here in the tension. This is the tension zone, and this is in a compression zone. So you can see here tension and a compression zone. So you can see the main reinforcement has been provided only in the tension zone is nothing but of a singly reinforced beam, and the reinforcement is from the bottom, that is a tension zone, also the compression zone, the both reinforcement which has been given is nothing but of a doubly reinforced beam. And here we can clearly see this. So we have two kind of a beam that we know, that is singly reinforced and doubly reinforced. Okay, that we have seen in this picture. And let me know which is the best. So if you go with a singly reinforced beam, so which is in a yielding, the doubly reinforced beams are always to over reinforced, and they do not prefer because at the time of collapse the concrete fails first without any warning. So we don't prefer the doubly reinforced beam. A singly reinforced beam would give you a chance to escape in this the design in the under reinforced beam. So you see the double reinforced beam, the concrete gets up first of all the collapse and not as in the steel. So here first the steel will get off collapse in the singly reinforced beam, and then only the concrete will get off collapse, so that we have some time to escape. That's the main thing in this singly reinforced and double reinforcement. And here we preferably go with the singly reinforcement. So if the depth of the beam is very lesser, so in case of singly reinforced beam we may go with the higher depth of beam. So for the reducing the depth, we may go for that double reinforcement beam. So that looks as an aesthetically, it will be in a very good, and the cost is slightly higher than the single reinforcement. That is double reinforcement. As we know, we are giving the reinforcement of main reinforcement the bottom and the top of this tension compression zone, so that the price will get of increase. And see the reinforcement beam ductility becoming the steel reinforcement. There is balance section, under reinforced section, and the over reinforced section. These are the three type of a section which has in the beam. The balance section we have, under reinforcement section we have, and over reinforcement section. These are the three kind of reinforcement section we have in the beam. And let us in the design part we will see what is this kind of balance section and under reinforced and the over reinforced beam, and limit state of collapse and limit state of serviceability. So let me have here what is the limit state method. So limit state method deals with the two parts, that is limit state of collapse and limit state of serviceability. So the limit state of collapse, we deals with the flexure, shear band, torsion, compression, and the serviceability. We deals with the deflection, cracks, and vibration. So which gives the serviceability to the structure. This is the one of the advantages of a limit state method, well comparatively with the working stress method, as we have seen in the first part of our video. And here it deals with a flexure, shear band, and a torsion and compression in limit state of collapse. So this is the philosophy of this limit state method, and which is so advantageous because it has a serviceability. And in the case of working stress method, it doesn't have any serviceability, right? So from the uh, ISO for 6, 36.4.2.1, we may know that the load of the table 18 page number 68 for the material, page number 68, that we know that uh, the partial factor of safety can be taken for concrete is 1.5 and steel is 1.15. And these are the some of the limiting values of neutral axis, that is XU limit, that you can see in the design that has been given in page number 70 and note 38.1. And to identify the neutral axis depth, that is, we know that we have a tension and compression zone in the beam, and it will be in a center line, the neutral axis. To identify the neutral axis, we have this formula, and which is in IS 456 2000, page number 96. And these are all the some of the formulas which can be identified for the under-reinforced and the over balanced section in IS 456 in page number 96 to identify the AST and XU max and MU limit and MU, and these are all the things. So you see the under reinforcement XU by D, which should be greater than XU limit by D, and XU by D is equal to XU by XU limit by D. So this is nothing but another balanced section. So as we have seen, the three kind of section: under reinforced, balanced, and over reinforced. So the over reinforced will be XU by D will be greater in over reinforced section. So for this section, we have a formulas here in page number 96 in IS 456. So let me have the over reinforcement. So as we said, in the over reinforcement, XU by D, XU by D will be greater than FXU by limit. So based on which the MU can be identified, and also the depth of the beam can be also identified based on the grades. So let us see the few uh, designing procedure for reinforcement, single reinforcement, double reinforcement beam. So first, the depth of the beam is based on L by D ratio, and the depth T by D should be between 1.5 to 2 meter, and minimum percentage of reinforcement as per class 46, A by DS is equal to 0.85 by Fy. And span range 3 to 4 meter, the L by D ratio is 15 to 20, 5 to 10 meter, 12 to 15 meter, 12 to 15, and about 10 it is 12. And the maximum number of bars in tension not less than 2 and more than 6. And minimum diameter for we use is 12, 16, 20, 22, 25, 32. And the width of the accommodation, the number of bars sufficient between the minimum cover is 20 mm for the stirrup. The anchor bar not less than 10 mm. So once we are going with some singly reinforced beam and we don't have any upper reinforcement, for that we will use as an anchor bar. That anchor bar should be of 10 mm. Check for deflection, and gentle width of the beam is 150, 200, 30, 250, and 300. So So this is a design procedure for an limited method of a beam. So first, we would like to find the data that will be given in your summers and the span of the beam, load, and the grade of the beam. So based on which we can identify the span of the range, we can identify the ratio, LVD ratio, and dimensions can be identified based on this ratio, and the effective depth and breadth can be assumed, and the effective span can be identified by the two criteria: center to center distance of support and clear span by plus effective support. So we can take which is the least. And load calculation, as we know, the self weight is length, breadth, and depth into unit weight. So the unit weight of the concrete, this is 25 kilonewton per m cube, and if it is in a plain concrete, just 24 kilonewton per m cube. Okay, and the total load can be calculated, and here we may able to know 1.5 into W, that is ultimate load. So we are using the limit state method. The ultimate load should be multiplied by 1.5. In the same case of working stress method, we don't follow this. And as usual, the bending moment. So as we know, based on the condition of the support of the beam. So as we seen in the first slide, the minimum type of beams with the based on support, simply supported cantilever and overhanging like that, and fixed like that. So if what is the condition which is given in the beam, so based on which the moment, that is bending moment and shear force, can be identified used on this standard formulas. So let me have to identify MU and MU limit. So we have to identify we have three kind of in a section, which is under reinforced or over reinforced. So which is a balance section is not possible at the 99.9% to 100%. But any one condition it will be applied for under reinforced section or over reinforced. So we already know the mu, and we have to find your mu limit based on this formula, based on the grade, and we can identify the section is under reinforced or over reinforced. So based on which we can identify from the section 9 page number 96 G 1.1b IS 446, we can identify the moment and the AST number of bars, and check for shear also can be done for the beam in the page number 72, which is in 73. And while solving this problem, we will see from this. And spacing should not be exceed 300 mm. And check for deflection can be also identified through the figure 4, page number 38. Check for, and based on the graph of percentage of tension reinforcement and modification factor. And deflection can be identified by page number 38 and 39. And KT and KC value can be taken based on the percentage of compression reinforcement and modification factor. And the deflection from KF value can be taken from page figure 6, and based on which three values we can identify LD by max and LD by basic, and which can be checked as a safe or not. So that's all about the session today. Just we have seen about the types of beam and what is the kind of in a beam, and what is the reinforcement we are giving for the beam, which is an under reinforced or over reinforced or in a balanced section, and what are the design steps we have done. And thank you one and all for the patience and looking for this video, and thank you.